Good morning everyone. This is series of lecture for T.Y.B.Sc Analytical Chemistry semester 6 student. The course of this subject is CH611A and chapter number 6 we are going to study, and its name is flame emission spectroscopy. Now in this lecture we are going to study the interference in emission spectroscopy. Now in previous lectures about the flame emission spectroscopy we have already learned about its principle, then now its working, some instrumentation part associated with the emission spectroscopy, how the measurement is carried out. Now the interferences in emission spectroscopy. Now the flame emission spectroscopy is nothing but the emission spectroscopy, because we know that that in the flame some atoms goes to the excited state, and that excited state is unstable and it will give back to the ground state, and during that time some of the radiations come from the atom, which is the emitted radiations, and so the name is emission spectroscopy. Here there are the three types of the interferences, namely spectral line interferences, vaporization interferences, and ionization effect or ionization interference. Now first is nothing but the spectral line interference. First we should know what is the interference. Interference is nothing but the interruption in the analysis. So here in the analysis some part is disturbed, or can say interference takes place because of the three factors, namely spectral line interference first, second is vaporization interference, and third is ionization effect. Now what is the spectral line interferences? We are going to focus on the spectral line interferences. First point is that it is closely associated with the resolving power of the wavelength isolator. Now here this spectral line interferences is closely associated with the resolving power of the wavelength, and now we know there is a monochromatic system, or can say optical system, which is nothing but the prism or diffraction grating. Now here prism or diffraction grating acts as a monochromator in the instrumentation, and this prism isolates the wavelength, or diffraction grating isolates the wavelength, that is a selected or can say desired wavelength. But sometimes there is an interference takes place, and it is associated with the resolving power of the wavelength. So it is close. The first point is that it is closely associated with resolving power of wavelength isolator, that is prism or diffraction grating. Now how it takes place? It occurs when a line of interest cannot be readily resolved from a line of another element or molecular band. So the reason is that it occurs when a line of interest, that is the desired line, that is line of interest means desired line, cannot be readily resolved from a line of another element or molecular band. Third point is that sometimes chemiluminescence or molecular fragments formed in the flame causes the molecular spectral interferences. Now along with the spectral line interferences, molecular spectral interferences takes place because of the chemiluminescence of the molecular fragment. So here this word is important. Chemiluminescence of molecular fragments, which causes the interferences, that is nothing but the molecular spectral line interferences. The example of this spectral line interference is that magnesium triplet. Now there are the three lines, so it is important to isolate the one line only. So here three lines are observed, and these three lines are nothing but the result of spectral line interferences. Similarly potassium doublet. Now potassium gives the two lines, that is a 404.4 and 404.7. so out of that one line is interest, so one line should be obtained, but here two lines are observed in the potassium doublet, so this is nothing but the spectral line interferences. Now the next point is that vaporization interferences. Now vaporization interferences, this is the second point. It is also called as chemical interferences. Now vaporization interferences is nothing but the chemical interferences. So why it is called as because in the flame there is a stable compound of analyte is formed, and this stable compound is nothing but the chemical compound, therefore it is called as chemical interferences. So vaporization interference is nothing but the chemical interferences. sometimes stable compound of the analyte is formed at the flame junction, which is not vaporized, and dissociated into atoms, therefore causes the interferences. So in the flame, if the analyte from the analyte a stable compound is formed, and that stable compound is gives rise to the vaporization or chemical interferences. Now how it can be minimized? It can be minimized, it is given in the third point, a selection of hotter flame. So we select a hotter flame which dissociate the stable compound, or we are going to add a chemical additive. So by using hotter flame or by means of chemical additive, chemical interference is eliminated. So this is all about the vaporization interferences or chemical interferences. Vaporization interference is nothing but the chemical interferences. Sometimes stable compound of analyte is formed at the flame which is not vaporized. So that analyte is not vaporized and dissociated into atoms, therefore it causes the chemical interferences. Now it can be minimized by two ways. First is by use of hotter flame, or by the second means, that is nothing but we use the chemical additive. So here stable compound is not formed, thereby we don't get the chemical interferences in the flame. Now the third point is ionization effect. Now in the ionization effect at a high temperature of acetylene nitrous oxide flame. Now here the example of the flame is the acetylene nitrous oxide flame. Now when its temperature is high, when the flame temperature is very high, for which type of flame? That is acetylene nitrous oxide flame. Its temperature is very high. At that time what happens? Ionization of alkali metal causes the excitation of atoms. So because of the high temperature of the flame, ionization of the alkali metal causes excitation of atoms, which is not expected. Now the excitation of atoms is not expected because atoms get excited because of the ionization process. So this is not expected because it reduces the number of ground state atoms and sensitivity of F.E.S method. So because of the ionization effect, because of the ionization of the atoms, what happens? It reduces number of ground state. It reduces the number of ground state atoms. So if the number of ground state atoms will be minimized or it get reduced, at that time we don't get this sensitivity, and therefore the sensitivity of the method is also get reduced. So ionization is the major problem associated when the flame temperature is very high. So because of the high temperature of the flame, ionization of the alkali metals takes place, and because when the ionization of alkali metal takes place, at that time it will causes the excitation of atoms, and this excitation of atom is not expected in the analysis because it reduces the ground state atoms and sensitivity of F.E.S method. So the second point is that how the ionization effect is minimized, that is given in the second point. This can be eliminated. This can mean that ionization effect can be eliminated by adding excess of an ionization suppressant. So we are going to add the simply ionization suppressant. So which type of ionization suppressant is added? Ionization suppressant is nothing but it is a substance which gives a large number of electrons in the analysis. So that is nothing but the definition of ionization suppressant. So this can be eliminated, means ionization interferences or ionization effect in the analysis that can be minimized by the use of ionization suppressant such as the potassium, strontium or cesium. Means out of that three we use the one only at a time. Potassium, either strontium, or cesium. We add the sample or standard solution. We add the ionization suppressant into this sample or standard solution it causes so ionization effect or ionization interference can be eliminated by adding a large excess quantity of ionization suppressant such as potassium, strontium and cesium to sample and standard solution. It causes the large number of electrons, preventing the ionization of element. So large number of electrons will be produced. By means of, if the large number of electrons will be produced, at that time ionization will be minimized or prevented. So this is all about the interferences in emission spectroscopy. Here are the spectral line interferences, vaporization interferences, ionization effect. These are the three types of the interferences takes place in the emission spectroscopy for the analysis, and they can be minimized by using hotter flame or by chemical additive or by ionization suppressant. So with this content I conclude this lecture. Thank you very much for your patience listening.